Hey guys, let's take a look at degree of equations. We're going to just a very short lesson today. Let's go back first and look at what is a degree of an equation. In other words, somebody says to you, oh, here's an equation, what's the degree? The definition of the degree of an equation is the variable that has the highest exponent value. In other words, let's say it's x squared plus x plus 1 equals 0. Well, since it's x squared is the highest exponent value, the degree is 2. All right? We've already done first degree equations with two unknown variables before. In other words, we've done tons of these. We've graphed, I don't know, y equals 2x plus 3 or whatever. Okay, that's a first degree equation because that's a 1 and that's a 1. Highest degree is 1. Two unknown variables, there's an x, there's a y. We don't know either one of those. We know what that is, right? If we graph that, what shape does that turn into? X equals 2x plus 3. Oh, excuse me, y equals 2x plus 3. It's a line, right? Okay, so we know those two. Let's look at three different types of systems of equations, and you should just be aware of all three of what these are called. There are three possibilities when you graph two equations, all right? Let's look at the first one. This is called consistent. Consistent. So get a piece of graph paper, pause it, and graph those two equations right there. And go ahead and pause it, and then come back when you're finished graphing the two lines. Okay, well the first one is y equals x plus 2. We know that's going to be right there. That's my y-intercept. The slope is 1 over 1 if you want to call it. And this is what it's going to look like approximately if I can draw a straight line, which I cannot. Okay, that's what it looks like. All right. Okay, this one, the y-intercept is -1. The slope is -2 over 1, so 1, 2 up, and then 1 over. And then 1, 2 up, and 1 over, and then you can see what happens here. It hits it right here. The intersection of those two lines will reach at the point x is -1 and y is +1. So x equals -1 and y is equal to +1. That happens to be, the -1, 1. That is the x and y value that will work for both of those equations. So in other words, when you have two systems and this is what happens, you can either, you can graph this and go, oh yeah, the answer is x is -1, y is +1. Or you can actually use substitution if you want to, or you can use elimination. Either one of those, any one of those three would work. You should get the same answer for all three of those. Oh yeah, I found out the answer, x is -1, y is +1. When there is one answer that matches both of those equations, it's called consistent, okay? All right, the second type is this. And I'm just gonna, pause it. Well, actually we just did something similar to this. We'll go ahead and do it together. This is the first one here, y equals x minus 2. We know that's gonna be down here, and the slope is 1 over 1, so it looks like that, okay? Now if you look at this second one, you graph it on the same, graph here. If you look, we wanna solve for y, of course, when we graph. But if you go ahead and divide by 2 on this one, that's going to be the 2 there, 2 there, and 2 there. Well, you get y is also equal to x minus 2, which is exactly what we start off with. And this will just be, of course, just right on top of the thing, right? There's no difference. So there's an infinite number of solutions to this. It's called dependent. Third type is called inconsistent. Now let's go ahead and graph the top one first. Y equals 2x plus 2. Well, I got 2 here. All right, my slope is 2 over 1. Boom, boom, boom. There we go. Okay, looks like that. I'm not going to, oh gosh, I think I missed every single one of those dots. Anyway. Okay, the second one is going to be y equals 2x minus 1. So here's our minus 1, boom. And then 1, 2 up, 1 over. 1, 2 up, 1 over. And then if you notice, this is a line if you were to do it like a halfway decent human being. They're parallel. So in other words, if you were to try to solve this thing using substitution or elimination, you would find, think about it. Look at this equation. Some number equals 2x plus 2. And then the same number supposedly equals 2x minus 1. You can take any number in the entire world. If you do the same multiplying to a number and add 2, and then the same thing and then minus 1, you can't possibly get the same number. It's impossible. In other words, these parallel lines are telling you there is no intersection. There is no solution as there was to this one. There's one solution. There it is, where the lines intersected. Well, the lines don't intersect at all, so there is no number on Earth that will fit those X and Y conditions to make that work out. Okay, there's no solution to that. Called inconsistent. Okay, you just have one practice problem, so go ahead and knock it out and see what you get, all right? Okay, so let's go ahead and do the first one. We have negative y equals negative 3x minus 2. Okay, well, so let's move that around and make it y equals 3x plus 2. So here's y equals 3x plus 2. Going to be 2 there. 1, 2, 3, and 1. 1, 2, 3, and 1. And then 1, 2, 3 down and 1. I'll try to keep this halfway decent this time. Okay. Okay, close enough. Okay, let's go 2y equals 6x plus 5, divided by 2, that's y equals 3x plus 2.5 or 5 halves or whatever. So we have 2.5, so 1, 2, and then there's our y-intercept. Oh boy, this is going to be a joy to get. Ah, brother, 1, 2, 3, and then over 1. Criminy. Oops, held it too long. Then 1, 2, 3, and then 1 over. There it is again. And then 1, 2, 3, and then over. Okay, looks like y equals 3x plus, good gravy, that's our first one. Then we have y equals 3x plus 2.5. Well, that isn't ever going to work, is it? Because think about it for a second. If I've done this correctly, let's see. Negative y equals negative 3x minus 2, so y equals 3x plus 2, that works. And then we have y is equal to 3x plus 2.5. Well, there is no such thing where you can go, oh, I get the same answer if I add 3x plus 2.5 and 3x plus 2. Not going to work. So these will always be parallel like this. And it's going to be inconsistent. There is no solution to this. So there you go. Okay, weird lesson, but we'll do more with it later. See y'all.